A standard chatbot returns text based on a prompt. An enterprise agent takes a high-level goal, decomposes it into a series of actionable steps, and executes them one by one. Take a look at the equation on screen. Most enterprise AI initiatives stall because teams deploy a bare language model. A model is just a reasoning engine. To build a system that actually accomplishes work, you have to surround that engine with memory, planning frameworks, tool access, and strict governance. Grab a whiteboard. We are going to spend the next 5 minutes designing a production-ready agent architecture. To keep things grounded, we will build a system designed to handle one specific task, processing a customer refund from start to finish. Scaling AI in production requires a shift in how you build. You have to stop writing isolated prompts and start architecting connected systems. Here's how we build the blueprint. This is the agent architecture blueprint. Looking closely at section 3, you will see a continuous cycle running between perception, reasoning, and action. This loop is the engine of the agent. The cycle begins here at input and perception. In our refund scenario, an angry email arrives from a customer with a broken product. The agent parses the unstructured text, extracts the order number, and identifies the core intent. The customer wants their money back. Next, the data moves to reasoning and planning. Instead of immediately drafting an apology email, the agent sequences a list of subtasks. It decides it must first verify the order history, then check the corporate return policy, and finally trigger the payment system. With a clear sequence established, the system moves to action. It executes the exact steps it just planned, retrieving the required data and communicating with external software. This continuous cycle of evaluation and execution creates a self-correcting machine that drives toward a result without manual intervention. A language model resets with every new session. To solve this amnesia, we have to build the structural memory systems shown here in section 4. Short-term memory handles the immediate context. If the customer sends 3 separate emails in 10 minutes about the same broken product, the agent holds those messages together as a single ongoing conversation. For long-term storage, we connect the agent to a vector database using Retrieval Augmented Generation, or RAG. This is where you store your massive, complex enterprise data, like your entire legal and policy documentation. When the agent needs to check the return window for a specific electronics purchase, it searches the vector database. It instantly retrieves the exact paragraph from the 50-page corporate return policy and applies that rule to the customer's request. By forcing the agent to pull exact rules from a vector database before it makes a decision, you anchor it to verified enterprise reality. This structural limit is how you prevent the system from hallucinating an incorrupt policy. An agent only becomes a scalable workforce when you give it the tools to manipulate external systems. Here in section 5, we grant the agent access to databases and APIs. Following the execution plan we built earlier, the agent pings your CRM to verify the customer's purchase history. Once the order clears, it securely routes a request to your payment processor to initiate the actual refund transaction. With the transaction complete, the agent hits an email API to autonomously notify the customer that the money is on the way. A chatbot reads a policy and tells your support team how to process a refund. An integrated agent connects to your APIs and does the work itself. We now have to choose the right structural framework for the task. Section 6 maps out the different ways to organize your AI workforce, depending on whether you need a single brain or a collaborative team. The single agent pattern operates exactly as it sounds. You reserve this structure for straightforward, self-contained tasks, like sorting incoming emails into folders. For complex enterprise workflows, we use a hierarchical pattern. Here, a central supervisor agent manages the overall goal and delegates specific subtasks to highly specialized subagents. For our refund scenario, we deploy a supervisor. The supervisor reads the angry email, delegates the policy verification to a strict compliance agent, and then handed the approved transaction off to a dedicated finance agent to execute the API call. Assigning a single agent to a massive workflow leads to errors, while building a supervisor network for a simple task wastes compute. Matching the architectural pattern to the exact use case keeps your infrastructure efficient. The final step is non-negotiable. Before any autonomous system reaches production, you must establish the boundaries shown here in Section 7. Input and output guardrails act as a filtration system. They block malicious prompt injection attempts from users and ensure the agent never accidentally leaks sensitive customer data in its responses. Role-based access control physically restricts what the agent can do. In our example, we restrict the finance agent's API permissions so it can only process refunds under $50. For any action exceeding that $50 limit, the system triggers a human-in-the-loop workflow. The agent prepares the entire refund but pauses execution, waiting for a human manager to click Approve before the API fires. Organizations will only trust an autonomous system with financial leverage when they can clearly see the transparent, hard-coded limits keeping it safe. You now have the exact specifications for an enterprise-grade agent. You have your continuous execution loop, your vector memory layer, the required API workflows, a hierarchical supervisor structure, and ironclad safety guardrails. When you zoom out, you can see how these isolated components integrate to form a complete, scalable enterprise engine. Integrating these components moves the project from a simple chat interface to a fully engineered production asset. Take this spec to the implementation team. Start with a simple use case, ensure it operates safely, and begin building the autonomous enterprise.